So thank you so much for folks taking time out of your busy schedules to be here. And I'm excited today to talk about kind of how you can inclusively assess student learning in undergraduate biology lab courses. So when I first started thinking about this topic, right, and thinking about assessment, we can think about assessment in lots of different ways, and especially if we're thinking about kind of inclusion in assessment, there's a lot of research out there about how multiple choice questions can be biased. High stakes tests tend to be less inclusive for women. Women tend to do better on low stakes assessments. So there's all kinds of things that we can think about in terms of more traditional ways of assessment. But I wanted to think more about kind of the uniqueness of lab courses and undergraduate lab courses and how we can think about assessment there. So thinking about how we can inclusively assess student learning, we really need to think first about backward design, right? So before we think about any kind of assessment in any course, lecture, lab, whatever, we have to think about the outcomes that you want to achieve, right? We have to think about the course goals, then we need to align the assessment with the goals, and we want as direct alignment as possible with those goals. If you're trying to get students to increase their confidence, giving them a survey that asks them how confident they are is a great way to measure their confidence. If you want to get them to learn how to pipette really well and you ask them on a survey how well they can pipette, that's probably not going to be super accurate in terms of their ability to pipette. And then once you think about what your assessments are, the third part of backward design is designing the learning activities of the course, right? So these three components of backward design is really best practice for any kind of course. So when we're starting to think about inclusive assessment, we need to think about what are the outcomes that we actually want to achieve in undergraduate biology lab courses. Why do we actually have students engage in these as a learning experience? So I want to give you the opportunity to engage, right? You're all probably coming from different meetings, different classes, maybe you're teaching, etc. So even though we're not in the same space, I want to at least virtually be in the same space. So go ahead and open up your chat and type out your ideas for why we have students engage in lab courses. And then go ahead and if you've typed it in, go ahead and push return and share it in the chat. So everyone should be able to see the chat. So I'm starting to see kind of the responses trickling in. Hands-on learning, experience discovery, practice physical techniques, improve critical thinking, gain research skills, how hard it is to collect reliable data, engage in the practice of science, learn about the scientific process. Science is all about doing, to have a research experience, to generate and analyze data, more opportunities to get experience than only working in a faculty member's research lab. Right, so we're seeing everything from this nuts and bolts skills of what students can actually do to more broader critical thinking skills, the opportunity to check a box and say they've done research if you build it into a lab course. Great kind of suggestions and ideas. So what I want us to do before we start to kind of untangle some of those is I think we have to take a step back and think about what actually constitutes an undergraduate lab course, right? And I used AI because I hear that everyone is kind of using it these days, just to do kind of a quick search for this. And this is what they came up with in terms of a definition. A lab course is a class that provides students with practical experience in a lab setting. Lab courses are often smaller components of larger lectures and can include hands-on activities like experiments, dissections, or data collections. And here are all the pictures that kind of immediately popped up in a Google search of this. So one, at first glance, it's kind of cool that the pictures are not your kind of stereotypical old white faculty who are men. We have some kind of diversification in terms of the pictures, but there's similarities in all these pictures of what a lab course is, right? Everyone is doing something where they're actually manipulating something. They're all wearing lab coats, right? And while this might look like your lab course that you teach or the lab courses that you have taken in the past, I would encourage us to think about is this definition restrictive of what we can actually do, right? And clearly, we can do lab courses in a lot of different ways, right? And so I would encourage us to think a little bit more broadly about an undergraduate lab course and think about it's some kind of credit-bearing course. It's typically taught synchronously, and students can engage in some kind of hands-on learning of science, right? And so sometimes this looks like pipetting, right? A wet lab, right? They're doing experiments. Sometimes they're out in the field though, right? People have lab courses that are ecology courses, conservation courses, right? They go out and into the field work. Sometimes this is in a computer lab though, right? Not wearing lab coats, right? This could be in a more traditional classroom, especially if you are using a previous data set that potentially someone else has collected and you're just analyzing it. Students are bringing their own laptops, right? And you're just in a typical classroom, right? Or then even during COVID, a lot of us taught lab courses online, right? We figured out ways to do this, right? And I love the mission of Brew More in that it's moving away kind of from language of lab courses to thinking more about experiential learning. And I think that this is really critical for all of us to start to think about, right? Because a lot of faculty, I think, have just a reactive intuition that a biology lab course has to be in a room with, a set of like things that you manipulate, chemicals or model organisms or whatever. But I think we need to really broaden that definition, especially as we're thinking about inclusion. Are there ways for students to get really important experiential learning, even with model organisms, that don't involve them actually doing the actual data collection? Are there ways where they can analyze the data? Are there ways in which they can engage in very different ways that are maybe more conducive to their identities and their backgrounds and their kind of current life situations, right? So I have kind of some of the reasons why students engage in undergraduate lab courses as learning experiences. These are things that faculty that I've talked to before have come up with, and many of your answers can be put on this list, right? People say you learn science by doing science, hands-on learning. Sometimes people talk about there's like kind of these seminal experiments in biology that like you can have students do, and that's really important for them. Some people brought up getting to do real research. So the term people typically use for this is course-based undergraduate research experiences or cures. And that's where you embed real research experiences where students are discovering things that no one knows the answer to that could be broadly relevant to folks. And you can do this in the context of a course. Some people talk about how research or how these lab courses are really important learning experiences and we can't do away with them because there's this awe associated with them. If you ask a lot of folks, like, what do you remember from, science in high school? They probably remember dissecting like an earthworm, right? Or dissecting a frog. And so there's a little bit of that emotion associated with that. Now, I think it brings up a really good question. Is that actually associated with student learning at the same time? And that's harder to actually tease out. There's also a lot of distractions associated with dissections, right? You've got the smell of things, right? You've got kind of the disgust feature. You have people who may be struggling with ethical implications, right? Or even religious implications of that, right? And so there's other stuff, and that's where it's actually really important to think about what are we trying to get students to actually learn here, right? If we want them to remember something, if we want them to be emotionally engaged, that might be different than learning exactly where the heart is in a frog, right? Or learn exactly like some kind of basic biological process. And then something that none of you came up with, which I'm not surprised given kind of the fact that you're taking time out of your day to kind of come to these things. When I talk to a lot of faculty about why we have to have lab courses, they're like, we've just always had them, right? I had them, like they're just a part of like science courses. We can't envision a biology degree that doesn't have a physical in-person course. And I'll push back a little bit on that because actually during COVID, almost all of our students were pushed through our programs without physical courses. I know that some institutions were able to still do it in distance way with small numbers of students, but in my institution, which is a really large institution, we couldn't do that. So we pivoted, and all of a sudden students who had always been required to have these physical lab experiences, all of a sudden we decided we didn't have to have them, right? Did the students lose out on a learning experience? Maybe, or maybe it offers an opportunity for us to really rethink was that a good use of time, right? Because the things that I want to think about actually as counter arguments for thinking about the biology lab course as this physical set thing that you come into one room and you do a lot of data collection, you do the analysis outside of class, right? Is it's really expensive. It's expensive in terms of the physical space, right? It's expensive in terms of the teachers, right? If you are paying faculty to do this is a lot of faculty's time. A lot of institutions don't pay faculty to do this. Instead, they have teaching assistants do it. But still it's an expensive thing, you know, and then of course you have the reagents and the equipment and all of that stuff. It's also really time intensive for fewer credits. And this has been something that I've been really perplexed with for a really long time. Why, if we think that lab courses are so important, if we think that that is the cornerstone of all of science degrees, then why do we only give students 1 credit for 3 hours of lab work? And I know that the argument often is, well, in a lecture course, right? Or in a lecture course, right? Like you get 1 credit per hour in person, but then you have a bunch of time outside of class where students are doing work. And and I assign students in my lecture class homework outside of class, but I think all of us, my students and myself included, we're all trying to be as efficient as possible and try to do the work in as short amount of time as possible, right? And so for students who are strapped for time, lab courses may be a reason they don't go into science, right? And that I think is a real equity and inclusion issue, right? It's also, you often get fewer credits for actually teaching it, right? And again, if this is such important, if this is such an important thing, then why is our system set up like that, right? And, you know, quite frankly, that's the case at my institution. And so I teach a course-based undergraduate research experience, but I don't need the physical setup because I do this in science education. So I list it as a lecture course. So it counts as a lecture course and I get more credit for teaching. The students get less in class time, and we actually get to do real research that actually many of my students have ended up as co-authors on publications coming out of that, right? And so I'm trying to work with the system to basically take that experiential learning and put it into a lecture course as opposed to a lab course. But I think that that's important in terms of thinking about how we define lab courses. And then do students learn best in that environment, right? Is there the expertise in terms of the instructors there, right? Is there, you know, is that kind of intensive time, right? The best way for all students to learn versus doing it in different ways. Again, I'm not saying we should ditch kind of your traditional lab courses, but are there different ways that we can think about? Some fully online programs don't require them, right? And they've thought about experiential learning in a very different way, even potentially doing it in asynchronous. And I'll push that I think that potentially having a physical lab course requirement might be a barrier for inclusion. And if we can't simultaneously argue why they're so important and what students are getting out of them, then maybe we should rethink that, right? And I think that that this group of folks is already starting to think about this. What are creative ways in which we can deliver experiential learning to students? How do we do this at scale? How do we do this in different ways to help meet the students kind of where they are? And if we think that it's really important for students to participate in these endeavors, what can be uniquely taught or better taught in a lab course than other types of courses, right? So some of you mentioned this is their chance to do real research. And I 100% agree, right? They can learn content in any course, right? They can, you know, the argument for physical kind of manipulation of something, I think it's important to think about, are you training students to be technicians? And if so, then that's really important. But if your students, if you're teaching them some kind of technique that might change in 10 years, then should that actually be your core goal, your primary goal of the course, right? So I think these are important things to just think about. No right answers here. It depends on kind of your priorities, but things to think about. So can you develop an experiential learning course that's more flexible for students and get more credit, right? And are your goals better suited to kind of a confirmation cookbook lab where students are following a series of steps to get the right answer? If you're trying to teach physical manipulation of something, maybe that's what you want. If you want to do a seminal experiment that you want students to experience, maybe that's what you want. I would say more often than not, we want to push people in the direction of more inquiry-based projects where students get to have more autonomy over the questions that they come up with. They get to have more kind of excitement about asking their own questions and potentially figuring out the answer. The difference really that I like to use between inquiry courses and course-based undergraduate research experiences is in inquiry courses, what the students are working on is novel and there's a discovery element there, but people don't really care outside of the course. You're not really going to publish that data. It's not really going to affect kind of anyone outside the course, but it can be an awesome learning experience for students. And they often get more autonomy over the specific question and decision making along the way. Versus a cure has both that discovery element and then in addition, that people outside of the course care about it. It might change someone's behavior outside of the course. It might be about something in the local community that then the local community can take those recommendations and do something different. It could end up as a publication that scientists kind of build onto, et cetera. And kind of the last phase of thinking about kind of experiential learning is research experiences in faculty members lab. And someone had the comment that there are far too many students than positions available in faculty labs. And so cures or course-based undergraduate research experiences are a great way to broaden participation from the angle of inclusion. And I completely agree. I would even go so far to bring up the point that we often think about research experiences in a faculty member's lab as the best experience possible, better than a cure. There's really no data that shows that. And I would argue in some ways that you probably can't mimic the very best possible experience in a faculty member's research lab. But cures are going to be a more standardized experience. So the research experience where the student is just forgotten about because the grad student graduates and people forget to like assign them to a new person, or where the faculty member gets so overwhelmed by something that they just stop like responding to the student. That isn't going to happen in a cure because there's more of those kind of structures and responsibility to the student as an instructor. Okay, so just some kind of things to think about in terms of how we define undergraduate lab courses and experiential learning in terms of thinking about kind of assessment. And if we build in research as part of these courses, then we also, when we're doing backward design, we need to think about not just course goals related to learning, but also course goals related to research. What research do you actually want to do in this course if you want to give students that opportunity to do real research? And are students actually making progress to that? And are you building in those activities, right? So that is an extra element here if you're building in research into your course in the case of a course-based undergraduate research experience. And I do want to highlight, it's possible to have tension between research and teaching goals, and I'm happy to chat about that further in kind of the Q&A, that in the ideal world, we increase research goals, we increase teaching goals, we get a ton of research done, we get a ton out of it where the students learn a lot, but there is the possibility that you could shift it so that you're being really productive in terms of your research goals, and you have the students just repeat one thing again and again. That's not ideal for student learning. And then you also could have the shift where you actually focus so much on student learning that you don't really make progress on the research. And so it's kind of borderline whether your course really would count as a cure at that point. Okay. So we can design and structure our lab course assessments in ways to promote inclusion, but we really have to be intentional in our decisions. And I would argue that we really have to pay attention to who our students are and what their experience is, both in and out of the classroom. And so I think an open question is, do we actually know who our students are, right? If you teach a class of 3 people, you probably have a good chance of getting to know who your students are. But if you're teaching a class of 15 people, 20, 50, 100, it's going to be far harder to kind of figure out who your actual students are. And we can go to the literature. Do we know anything kind of broadly about how lab courses affect students differentially based on who the students are? And if you look at the literature, including papers that I've actually written, I say that course-based undergraduate research experiences are effective learning experiences, right? We've advocated for them to be used to broaden participation in research. We have talked about the positive impacts that they can have on students' critical thinking skills, their ability to analyze data, their ability to design their own experiments, their science identity, their confidence in science, their intention to pursue future research experiences. all of these things. But we also have to start to ask who's actually represented in that literature on course-based undergraduate research experiences. So whose students are in those papers that actually shows that these are good experiences. And so before I show you some data that we actually collected on this, I want you to go to the chat again, and I want you to think about these different aspects of who students are, their GPA, their social economic status, maybe if they struggle with mental health. What information about students do you think is least represented in the published literature on undergraduate research experiences, like course-based undergraduate research experiences? So what do we know the least about in terms of who our students are when we look at the data that exists showing that cures or research experiences are impactful on students? So go ahead and think about it a bit, and then go ahead and put your ideas in the chat. Okay. I'm seeing a lot of really good ideas there. People are focusing on a ton of stuff: neurodiversity, disability, commuter status, work, mental health, um, right? Commitments outside of school, all really great ideas. So we wanted to know what was actually happening. And part of the reason we actually did this project was I was teaching a course-based undergraduate research experience in science education, and COVID happened. So we realized that we needed something that could be done where we're not actually collecting data, because a lot of the in-person classes that we tend to be interested in had all shut down. So we wanted to do something where we could look at the literature. So we actually did this as a project in a course-based undergraduate research experience. We did a project on cures. It's a little bit meta, right? But we reviewed the published literature on undergraduate research experiences, including course-based undergraduate research experiences. And we looked at 268 articles that have been published from 2014 to 2020. And we chose that time because after there were some key documents before 2014, Vision and Change, some key documents and reports that had actually coined the term course-based undergraduate research experience. So it was something that more and more people were starting to be aware of. And we wanted to see basically, what do they say about who their students are in these articles? We found that 27% of articles don't report any student demographic at all. So these are all peer-reviewed articles in science education showing some kind of impact on students as a result of the cure. 27% don't mention who the students are at all. I would argue that's potentially problematic. 1 out of 4 papers doesn't say a thing about who the students are. So when you look at the results, are these really elite students that are honor students, right, who have been pre-selected? Are they students who are really struggling as they're coming into college, and this cure is an opportunity for them to try to engage in the material in a little different way? We just don't know, right? Now, if they do report demographics, they mostly report gender or race ethnicity. Typically, they're reporting gender as a binary, as male, female, or as men, women, as opposed to giving a spectrum or a non-binary option. But these are by far the most common demographics that people will collect and report out. But based on what you were predicting, you're exactly right. So most of the studies don't report GPA, prior research experience, social economic status, career intentions, language, disability status, employment status, commuter status, mental health, LGBT, etc. Right? Even though we can look at this and theoretically we can be like, wow, career intentions probably really affect someone's experience in a cure. If they want to go on and do research, they may be way more engaged in a cure than if they are just trying to do this course as their science kind of elective that they have to take, right? If they've had prior research experience, that experience in a cure probably is very different. They may already know what it's like to have, to be in a research lab and to have even a publication. And so maybe a publication that you're getting out of that cure isn't actually as kind of a big deal, right? So all of these things we can start to think about. So to actually show you this kind of graphically, we looked at both who reported these demographics and also who considered them in analyses. And we are interested particularly in who considered them in analyses, because then that tells you, okay, well, men compared to women maybe scored higher on this or that, right? So very few reported, but those that report, there were some that considered them in analyses. But again, you can see it's gender and it's race that people are considering and reporting, and most of the others we're not talking about at all. Now, we looked at cures versus independent undergraduate research experiences in faculty members' labs, and we suspected that cures were going to have more of these data collected because there's more students and you can just do a survey, et cetera. But actually, cures were less likely to actually report some of these demographics, which we were really surprised by going in. So if we don't really know who our students are, this is going to be a major challenge for inclusion, right? So now if we're thinking about kind of common assessments that you might use in lab courses, it might be quizzes, multiple choice questions, pre-lab assignments, post-lab. You might look at daily participation. There might be some kind of lab practical. There might be writing exercises, a final poster presentation or oral presentation, actually producing some kind of product. Like sometimes in chemistry courses, you actually have to produce the compound. You might do peer review of each other's work, so students evaluate each other, or maybe students actually say, hey, this group member didn't do anything, they were lazy, this group member did all of the work, right? And then people get credit based on that. Sometimes the work in a lab course is done in partners groups. Sometimes it's graded individually versus for a group. Sometimes it's graded for effort versus accuracy. All of these things are things to think about in terms of inclusion, as far as inclusive like assessments. And so I want to ask you to share in the chat one more time. What might be issues thinking about those kind of different assessments as far as inclusion and assessments for a lab course? What are things that kind of pop up in your mind based on either your own experiences or maybe what you've read places? Yeah, what might be the tricky spots for assessments and inclusion? Okay, I'll just wait a couple seconds for the kind of ideas to pop in. They're slower to pop in because this is a harder question, right? If you think about it, right? Like we're used to kind of just assessing students and then taking a step back and being like, are there ways in which we're assessing them that could be non-inclusive? That's harder. So some ideas that came out: non-native English speakers of English, how's their communication skills? You can think about that both oral and written. Quizzes or tests, does that actually measure the goals of the course, going back to making sure that there's actually that backward design and alignment. Student evaluations of group members, if they know them before class or if they have other negative interactions kind of outside of class. Unfair distribution of work. A lot of people are talking about disabilities and accommodations, like what that would actually look like. Awesome, awesome ideas. So I want to kind of unpack some of them before we kind of go into the Q&A. So student social identities may be more apparent in lab courses than other types of courses. If you're in a large lecture course, you can kind of just go in, sit there, kind of ignore people. But in lab courses, you're often working with other people, you're partnered up with someone, et cetera. You're often staring at someone across that lab bench. So who you are, your identities are going to just be more apparent. There's going to be more time during lab courses when you're waiting for something to happen where you might have kind of casual conversations about what you're doing this weekend, et cetera. And all of this makes who people are matter more, right? Oh, what are you doing this Sunday? Oh, I'm going to church, right? Like that might come up, right? Or, it might be conversations about dating, and that might affect LGBTQ folks differentially from non-LGBTQ folks, right? All of this can add to the cognitive load for students who have some kind of marginalized identity. Either they're minoritized, they're kind of the only ones with that identity in the classroom, or that there's some way that identity is marginalized in terms of how they feel and kind of disadvantaged broadly in society or even in the context of science. And this could affect their own participation in the course, right? So we often think about, when you look at groups, someone is participating more, someone is participating less. Well, the person who's participating more, well, they're better, right? They care more, they're more engaged. Well, what if the student who's not participating is less comfortable participating? Maybe they're from a culture where you often don't talk your ideas out loud, like kind of typical like white American culture, right? Maybe they had to work late, so they didn't do the assignment coming in, so they don't want to participate because they don't have anything kind of to add. There's a whole bunch of different factors that could affect participation. Even one person completely dominates, so the other person doesn't even get a chance to participate. So yes, they didn't participate, but was it actually their fault? Who takes on leadership roles in groups? Who gets to touch the equipment? That's something to think about, right? Is it equitable, or does one person always get to do it? Does the best person get to do it? Does the most aggressive person get to do it? Who actually makes decisions? Who answers questions in whole class discussions and gets kind of status for answering questions? Who asks questions in front of the whole class, right? And although there's less work done kind of in the context of lab courses, there's work from biology lecture courses showing gender disparities in participation. Women are more likely to be listeners in groups. Men are more likely to take on self-described leader roles. Women are more likely to say that they don't participate as much as men in groups. And if you look at who asks and answers questions to the whole class, for answering questions, we know that that men are more likely to answer questions if it's just a volunteer. You can do random call, but then that creates a bunch of other issues with student anxiety. And we know that student anxiety can really be activated by random call, where you have kind of a randomized list of students' names in the class and you just call on them. We know that student anxiety, just in general, affects participation, particularly sharing out in front of the whole class. If you work with people more often, you get to know them more, that becomes more comfortable, their anxiety goes down, even if they have social anxiety, but that's a consideration. And we've done work actually that shows that LGBTQ students, particularly transgender students, may feel uncomfortable in assigned groups because they're misgendered, because especially if they're in early stages of transitioning, they may not feel like people accept kind of how they feel. They also may be really struggling with kind of body dysmorphia in general. And so being in physical spaces, interacting with people can be challenging. In addition to all of those are what the student themselves is experiencing. They are choosing not to participate in some way because of some factors, right? Or they're maybe less comfortable. But also identities, backgrounds, and prior experience can affect how other people treat them and assess the quality of their contributions and work, both instructors and other students. So there's studies that show that men in general, students, underestimate the academic ability of women in biology classes and overestimate their own perception of their academic ability. We actually looked at students who were average students in the course, and women who are average students were like, yep, I'm an average student. I'm smarter than about half the class. And men were like, nope, I'm smarter than like 60% of the class, right? So this overestimation of their own ability may actually change how they rate other people in inaccurate and unfair ways. There's also implicit bias. We all have implicit bias. So this is, you're not maybe not conscious of your bias, but it could affect anything that's subjective. If you are evaluating someone's writing, if you're evaluating their oral presentation, if you're evaluating whether someone's participating to the same rate as someone else, right? We have to be conscious that there's been implicit bias documented among faculty, both in terms of gender bias. Faculty are more likely to hire men, mentor them more, and pay them more, even with all things being similar about a candidate, except for just an obviously female name versus an obviously male name. Study has also shown that faculty are more likely to respond to emails from white sounding names compared to black sounding names, right? So there's all this implicit bias that everyone has, but it's affecting subjectivity of things. And then someone answered this as far as communication ability with English as a second language students or students who grew up in their home speaking in a language other than English. Are you actually assessing writing ability, or are you using written materials as a way to assess understanding of science, right? And you may be thinking, oh, I'm measuring their understanding of science, but you're actually measuring their English comprehension and their actual writing ability. Also, student social identities may interact in different ways with how they respond to a course with real research, like a course-based undergraduate research experience, as far as knowing what research is, why it can be useful for them, worry about failing, as well as engagement in all the research aspects of the course, right? So what if a student's research fails? We know that student depression is negatively affected by failure. Sure, it's bad for everyone to experience failure, but people who have depression view that failure differently. And if you are someone who has depression, I have depression, that probably resonates strongly with you. If you don't have depression, you probably don't understand that as much. And when something negative happens, it's not like it just happens. All of a sudden you globalize it. That is true of everything. That failed because you are intrinsically bad or wrong, right? Not that you made a single mistake. And that's just a feature of depression for a lot of folks. We also have looked at actually this idea of research anxiety, and we're coining this term to describe the anxiety that students have specifically around doing research. And women and students with higher grade point averages are more likely to report higher levels of research anxiety, and it actually negatively predicts their interest in going on into scientific careers, doing research. We also have to think about if students have vastly different skill sets. How are you doing this in the class, right? Are students motivated to have the more skilled student complete tasks to be faster or more accurate, especially if accuracy is built into how you're assessing students? Or are you building it in so students have turn taking and so everyone gets to actually do that task and learn from that task? Do you expect students to stay late or come to lab outside of class hours to complete aspects of a project, right? I think most of us know with real research, things go wrong, right? Things take longer than expected. So when class time ends, do you expect students to stay later? And is that fair for students who maybe have to work, who have to commute, who are primary caregivers, right? And even if you allow students to leave, do you look at the students who stay as better students? Do you say, hey, they are better students, they're more committed, when that's really not fair if the students sign up for a course where it was only supposed to meet for a set amount of time? You also have to think about, are you asking people to come back the next day to take plates out of an incubator or something? Those students who are having to commute 45 minutes, that's a lot of time to move one plate out. Can you or can someone else do that, right? And how are you handling accommodations if the class as a whole is working together on a research project, right? So typically with accommodations, flexible attendance, they can make up the work. Well, how do you make up the work if the work is all of you working on a research project together? Are there more authentic ways of actually having students be accommodated where they still can have flexible attendance, but they can actually still, whatever they're working on to make it up, still moves the research project forward as opposed to just doing kind of a pointless task, right? So big picture, inclusive lab course teaching strategies that highly influence assessment. I would encourage limiting group size and assigning roles, right? To structure those groups more than just like let it kind of be however. Smaller groups have less potential for one person to completely dominate. Consider group composition. Are you letting students form your own groups? Are you setting up those groups? There's pros and cons with both, but it's something to think about. Error framing. Are you helping students realize that making mistakes is totally normal, natural? It's part of doing science. If you don't feel stupid, you're actually doing something wrong in science, and helping students see that. Explicitly state that you want to create an open and inclusive lab environment, but also limit asking students personal questions during downtime unless they want to share, right? So that's something you want to be really careful about, especially in the context of lab courses. If you're waiting around, like if students want to share something, it's up to them to actually come out, to share something personal about themselves, etc. Evaluate your assessments to see if they're measuring what you think they are and whether you convey your expectations to students. Use intentional instructor talk, especially if you're doing a course-based undergraduate research experience, to unveil those unwritten rules of research. What is a publication? Why do publications matter, etc. Be mindful of the lives and other commitments of students. If you are planning to lead to a publication with your real research, make sure that all students have equal opportunities to become authors. A pet peeve that I have is some cures have been developed where they haven't kind of kept track of students along the way. So the students who still have an active email address end up getting to be co-authors. The students who don't have an active email address don't, and that's just intrinsically unfair. Build in opportunities for students to share data, right? So you can feel as you're part of a larger team, and if they fail, their team as a whole can still succeed. And consider authentic accommodations for students with disabilities. And with that, I'll kind of take any questions as we think about inclusive assessments.
Thank you so much. That gave us a lot to think about. If you have a question, you can enter them in the chat, or you can unmute and ask.
Hello. So you mentioned group composition as being one of the things that can make group discussions more equitable. I've heard from other researchers that actually has like you said, there's pros and cons. There's possibilities, for example, when organizing groups alphabetically, that you are accidentally grouping people by race based off of the different variations in names based off of that. And there's a danger of tokenism, wherein you have every group assigned their one, I don't know, their one Asian kid, which is putting a ton of pressure on that student to be then the representative, and it is not actually allowing them to engage in the material in the same way. So whenever you are considering group composition, how do you take into account those fears of tokenism, while still making sure that students are able to be open to new experiences that they might not have otherwise have had?
Yeah, that is a really, really good question. And something that the research literature is really mixed about. I think that the important thing to consider with groups that not enough people think about when they have this exact conversation is, what is the point of the group? So sometimes I have students turn to people around them to talk about a problem, but they're not trying to actually create any kind of product. And it's really just meant to be an active learning engagement opportunity for them to bounce their ideas off of someone else. In that case, then I want them actually to be as comfortable as possible in that group. So I don't want that group to be a group that they've never talked to before. Ideally, those are people that they feel comfortable sharing ideas, that they feel comfortable taking risks with in terms of coming up with an idea that may actually be wrong, and they don't feel kind of as judged, or the kind of technical term for that is fear of negative evaluation. So in that case, I let students pick their own group, right? And that's and again, a lot of the research showing that an increased diversity of folks in a group is better. It's better for the final product. It's better for the final product that you're trying to create because you're counteracting each other's biases. In the case of just turning to each other and talking, I'm not trying to create a final product. What I'm interested in is individual student learning in that experience. And I know based on the data that exists as far as active learning, that that process of talking is going to, on average, be better for students. I also want to point out that I don't force all students to turn to groups in that case. There might be a student on that day that is having just a really bad day, and just coming to class, they just want to kind of sit and absorb and think on their own and don't want to talk to someone, and talking to someone would be way too much social engagement, and that's okay too, right? So that is kind of my philosophy. Now, when it comes to lab courses, typically you assign a group and there is some kind of product that they're trying to do, right? So that is a little bit more of a justification for why more diverse teams would be better. But then I think you really have to think carefully, is your product so hard, and do students need to like have different ideas and different perspectives and different backgrounds, and that will actually influence the final product? And I again would argue that most of our lab courses, including cures, don't give students enough autonomy to actually do that. So I actually don't think that the diverse opinions actually is something that we should be thinking about a ton in cures, because I don't think it's actually helpful for the final product. Now, there might be some cures that students are really engaging and coming up with different ideas, and that might be the case. But I would say for most of them, that's not the goal. So for most of them, again, the goal of that group is to be a positive working situation, to work on a task that's often largely defined by the instructor. And so with that, I agree completely that being the only woman in a group or the only Asian student in a group, like that might feel like tokenism, and that might actually feel really less comfortable. And so again, my philosophy and the way I do it is I let students self-assign their groups. So I let them, when they come into class, into the kind of lab section on the first time, wherever they sit, that's where their kind of group is. There's some data that shows that LGBTQ students in particular, the first time they enter a classroom, they kind of do a sweep of the room and they use total stereotypes, and they highlight that this isn't necessarily right and they don't agree with it. But basically anyone who looks obviously religious or obviously kind of conservative or Republican, they avoid, because they're like, they could be accepting of my identity, but it's not worth the risk. And so again, for those students, for me, I think it's more important that they pick folks that they feel like are going to be more comfortable around, right? And so, But again, I think it just depends on your question. But a lot of people have really strong viewpoints on it, whether you organize it totally randomly, right? You could do randomly. You don't have to do alphabetical lists. You could do total random, and that shouldn't change it based on kind of name. Some people prefer to do it based on, you know, this is an A student, this is a B student, this is a C student. Again, I think there's pros and cons to that. I just let students choose their own groups because I'm less interested in a diverse group, and I'm more interested in a group where the students feel like they can maximize their learning.
Thank you.
I have a question.
Sure.
So you discussed something that I've seen kind of anecdotally about student failure in the lab, perceived failure, and the anti-correlation with GPA. And so I teach a lot of molecular biology. There's a high failure rate with a lot of those experiments, and you can tell the students to be prepared. But then there's the experience of going through it. I mean, one of the ways that I try to combat that is by using the sense of collaboration. So if like group 1 gets it, then group 7 can borrow group 1's material, and that helps a little bit. But I didn't know if you had any other suggestions as far as getting students ready. I comment on my own, 1% success rate in life, and maybe that helps them a little bit too. But if you have anything that you could suggest, I would appreciate it.
Yeah, absolutely. I mean, your 1% success rate is essentially error framing. You're normalizing that. You're saying, even though I'm in this position of authority in the classroom, and even though, like, I've been able to get to where I am, I failed a lot. And this is a normal part of the process. That, I think, helps students. They realize that. It's also really important that, like, one-off statements or comments can really have a huge impact on students, right? So, like, if they mess something up, how are you responding? Are you responding in a positive way? And I know that this is hard, right? You're trying to juggle a lot of things. Like, a student might have screwed something up for like the 50th time, right? And so, like, how do you kind of build it so, and especially if it's a cure, you also probably care about them doing it accurately and doing it well, right? And so that's where there's a little bit of that tension, where it's important for you that the data is actually good, but also you want to be supportive of the students that are novice students making mistakes. So I think it's important to look at, is it a mistake or is it just failure as a part of science? And I think that that's an important distinction that I don't hear people talk about enough, right? That you clearly, there are things that you like mess up, right? Like, if you like run a gel in the wrong direction, that is not because science mostly fails. That is because you messed it up. You can share with them, when I was in grad school, I messed this up. Like, people mess it up, right? That error framing is different than saying, oh yeah, science always kind of fails. So I think that distinction is important. And then even highlighting that sometimes your mistakes you can learn from, right? Whether it's you're never going to mess up that running of the gel, right? Because now you're extra careful, or you've developed some kind of mnemonic to remember that, or like, was there something totally weird and unusual that happened that now you discovered, right, because of that mistake? So I think those are things you can potentially do. But I think a challenge also with that is every student is going to respond to failure in a slightly different way. And again, like, based on what we know with student mental health and anxiety and depression, they're likely going to respond to failure differently than a student who doesn't struggle with some of those mental health challenges.
We have a couple of questions in the chat. If I can read out the first one. Any tips or resources for group lab work when some students are hard of hearing or deaf?
Yeah, that's an interesting question. So I want to start off by saying that, so when we think about students with disabilities, almost immediately our brains often go to disabilities associated with sensory and physical impairment. So we often immediately think about the blind kid, the deaf kid, right, or the kid in the wheelchair. I will say that the vast majority of our students with disabilities and the vast majority of our students who need accommodations are not going to be those students, right? The vast majority of them have what would be considered invisible disabilities, and primarily those are learning disabilities, psychological disabilities like mental health challenges, ADHD, autism, those types of things. So I just want to kind of preface it with that. For lab work, if students are hard of hearing or deaf, if they have a formal accommodation, then likely there's some kind of interpreter, right? That's coming. I think probably the bigger issue is you have a student who doesn't even necessarily know they're hard of hearing, or it's not severe enough to be able to kind of warrant one of those accommodations, et cetera. Things that I always encourage is make sure important information is on the slides. So it's not just what you verbally are saying, but also what's on the slides. Group work can obviously get really loud, and that is really hard often for students who are hard of hearing, to be able to kind of hear what's going on. I don't have great tips for that. Rooms are echoey. So yeah, and then I guess the one just really concrete thing is always use a mic. Like if you're giving a talk, use a mic. Like if you are in a classroom, ideally you're using a mic. If your classroom doesn't have a mic, you should be able to request a mic. It is just way easier to hear with a mic. And a lot of people are like, oh, I can talk, that's fine. No, it's much better with a mic.
Thanks so much. So there's several questions in the chat, but we're getting close to out of time. So I'll read out one more, but then if you have the time and ability,
Sure.
Sarah, to answer a couple other ones in the chat or
Happy.
follow up with people. Awesome. So this last one is that you pointed out many of the educational research doesn't include various factors of a student's identity. How may we include this data as we study learning in lab courses without making students feel uncomfortable or adding confirmation bias or other unintended negative consequences?
That is a really, really good question. And something that I do before every one of my classes is my first week of class, I give students basically a survey that I set up. You can set it up on Google Forms. I set it up on Qualtrics because my institution has access to that. And I basically say, I want to get to know who you are, because I want to not make assumptions about who my class is. And this is a way that I can make changes in my class to better kind of teach you. And then I ask a bunch of questions about who they are, what their career is, how many hours they commute a week or like a day, how many hours they work, whether they identify as having disability, whether they identify as having depression, LGBTQ identity, anxiety, whether they're religious. All of these different questions. I do a bunch of things with the questions. One is students could skip any question they're uncomfortable answering, and there's always a decline to state. So they never feel forced to do that. And I just frame it as I want to get to know kind of who you are. And then so we've actually done some studies to say, okay, like I informally got some feedback from students, but then we were like, okay, does this actually affect students in a positive way? And we actually just published a study this past fall where we looked at the impact of doing this survey on students, and the vast majority of students don't feel uncomfortable and don't feel like it's negative. So most of them feel like it's actually positive. Some of them are like, it's neutral. It's just like answering some questions about us. That's all. But most of the students say, I like being able to kind of share who I am. I like that the instructor is using this information to change some things in the course. And it'll be simple things like, oh, this percentage of you want to be vets, right? And this is why we're giving this particular example in the class, right? Or I'm like, I had no idea how many of you were working more than like 15 hours a week. I'm going to try to be as efficient as possible in like my expectations for homework outside of the class. So if you do it like that with those intentions, I think that students don't feel like, that you're like studying them, but actually that you're doing it in a way to try to help them. And then also what I do is I actually take the data, I summarize it, and I actually show the students actually the data so they can see that there's a lot of students who share their similar identities. Now, the caveat to that is if there's like one non-binary student in the class, I don't put that up on the histogram. I made the mistake one year of doing that, and a couple students laughed, and I screwed up as an instructor. I didn't say anything. I just like froze, right? And so now I'm very thoughtful that if there's too few people in a particular category, then I make sure to bundle them, or I might not show whatever that kind of identity is. But this way they can see that, hey, like half of you struggle with depression, like 30% of you struggle with anxiety, right? And like they can feel kind of more like they belong in the class.